Hello, my name is Pavel and I continue to introduce you into the temDM package for multivariate statistical analysis. In the previous tutorials we did the PCA analysis of an else example. Let's open that, and for brevity let's open compressed file. Here we are. Okay, today we will deal with rotation of the PCA results. So what is that? PCA is also some kind of rotation when you express your data not in the original energy channels but in principal components, which are the new linear combinations of the old channels. Now we will continue to rotate in such an abstract space, but it would be one important difference. In PCA we choose several principal directions and discard the other ones. It means that in that example it was 2000 energy channels, 2000 dimensions in energy space, and we reduced that to 5. And let's continue to rotate, but now in reduced 5-dimensional space. Why we might wish to rotate? Remember I told you that the obtained PCA loadings are typically abstract, uninterpretable, but hopefully they can be more interpretable if we just rotate the coordinates. So let's open the rotation tool, rotate results, and there are 3 available rotation methods: independent component analysis, Varimax, and free rotation. Also you have to specify the plane where you want to see the results of rotation. We start with independent components. Press ICA and you are prompted to choose which axes have to be rotated. We choose all 5. Rotation starts. You see 5 by 5 pixel rotation matrix. Actually system is searching for the direction where data distribution differs maximally from the Gaussian one. Here you see the new scatter plot. It's really rotated. Then you see new ICA loadings. Hopefully they are more logical than the PCA ones. And also, instead of variance for each component, we have plots of so-called kurtosis. Kurtosis is a measure of non-Gaussianity of the data. It might be negative or positive, but in modulus it must differ from 0. And here we see that the first 2 components really differs from 0 significantly, while the rest components approach 0 kurtosis. As usual, we can close all these plots without saving, because they are all stored automatically in the compressed matrix. Close that as well. Rotation matrix is not stored, but I don't think we need that. Just close. Now let's explore another rotation method. Press Varimax, and to save time we rotate only 2 components, because we know the rest components are just noise. Rotate. Rotation starts. Now the system is searching for the maximal sparsity of the obtained components, but at the end you see that the scatter plot is not rotated significantly comparing with the PCA one. That's because the simple straightforward rotation in that particular case is not able to achieve high sparsity. Let's close everything and try something else. There is a variant of rotation where you can redefine the rotation center. Let's click Varimax C. For the moment you can do it only manually, and of course within one plane only. You see here the scatter plot of first 2 components, and red point is our rotation center. We just drag it to that position. I think that is a logical new beginning of coordinates, and press new center. Well, again we have to define which axis to be rotated. As previously, we rotate only first two axes. Rotation starts, and let's see what would be the difference. Okay, now you see that scatter plot is much more logical. The main variation trends more or less coincide with the new axis. And you might see that the loadings are also much more logical comparing with the previous cases. Let's close everything. As usual, no saving. That brings us logically to another strategy. Completely free rotation. Click free. Why not adjust manually both the rotation center and the direction of rotation? We will do. Here we have a red arrow, and the beginning defines the rotation center and the end defines the direction of the rotation. Most conveniently is to find the right direction by looking at live resulting loading. So here we play a little bit with direction and we see how loading changes, and we find the most logical to our mind loading. For instance, let's achieve here smooth spectrum with no peculiarities. Then we find the right center and direction and press rotate. Well, there is no any optimization behind this process, just simple rotation. However, it can be efficient. Here we see a new scatter plot, and at least one axis is precisely along with the loadings, which is logical, at least for our mind. Okay, let's close everything. This free rotation is of course subjective, but it can be useful because, you know, human brains are so clever that sometimes they can pick up the right solution where all powerful algorithms fail. But because of subjectivity, the system allows to do such a rotation in steps. You can run free many times, and every time the next step will start with the result of the previous step. Here we have the previous position of red line, and we can adjust it a little bit and press rotate again. It's also recommended to do such steps with alternating viewing planes. For instance, you start with plane 1, 2, then continue to adjust in plane 2, 3, plane 3, 4, and so on. But please always at the end be back to the original plane to see how everything looks like. Sometimes, as a result of this iteration, you come to completely crazy situation, and in this case it's better to press erase, confirm everything, and the next step would hopefully start from scratch. Yeah, it's like it was in the beginning, and we start new rotation, this time for instance like that. Now we have chosen another trend as the primary axis. Good, close everything. Well, today we learned about the rotation tool. There are another tools to be explored, and members and clustering. Please join us for the next tutorials.